Hey everyone. See if it works. Cool. I hope everyone's comfortable. There's pizza digesting in your tummies happily, beer in a hand, or beverage of choice. Who am I to judge? So since this is my first time speaking here, sorry, I'd love to share with you all the journey at my current company, with a focus specifically on architecture. So let's see if this clicker works here. All right. Before we start, I would like to say all software has an architecture. However, the design and planning within it is completely up to each team. And I'm not standing here to encourage anyone to convert their project to our architecture or any architecture for that matter. Nor am I here to say that one kind of implementation is the way to go. So with that out of the way, let's start off with some questions that I frequently ask myself. So if you are, what does building scalable and maintainable software look like? And as you work on a project long enough, you tend to have all these kind of questions like, how do I scale up? How do I modify and extend my current features? Things like that. How do I know I'm building something the right way? Is it like a gut feeling? I don't know, maybe it's just me. I walked into a really messy code base. Ooh, now what? I walked into an overly engineered code base. Now what? So if you ask Google, depending on your choice of words related to architecture, you will get a multitude of different ideas on how to implement stuff and how things should work. So I hope that we can all use this talk to really distill what I would call the essence of what is good in them. So with that said, hi, my name is Jason. This is me 3 years ago at Silicon Valley. This is a beverage of choice. I love ale, especially red ale. If you love ale, hit me up, we'll get ale. Love that stuff. And this is my wife and cat. I work at Punters. We deliver racing stats and form data to the everyday punter. Our feature set includes tons of awesome stuff like news, forum, live chat, just for everyone to, and all with the aim to make horse racing more awesome. So let's talk about the iOS app. So the journey here started in mid-2014 in Objective-C, and that was the standard at the time. And then the developer at the time saw that Swift was kind of up and coming, and I think it was Swift 2.0 at the time, and he started rewriting tons of classes in Swift, and that was the end of 2015. And I joined mid-2016 and continued writing Swift, and sometime in the previous few months, we completely moved everything from Objective-C to Swift, native, of course, excluding third-party dependencies. Let's talk about the architecture journey now. So, MVC, as prescribed by Apple, and that's how everyone started at some point. In 2014, moved to MVVM in 2016, and that was around where I joined. And we did MVVM a little without the use of bindings, because we didn't really have a reactive framework or anything that could bind objects together. So we sort of winged it ad hoc a little bit, and then we started to go on this journey to a new architecture called Nemo. And Nemo was the team's attempt to find commonalities in our daily programming tasks and make a pattern out of them. And that was also about the time where we introduced the Reactive X, aka RX Swift, particularly in our case, into our app to improve communication across the objects. So, of course, and then in mid-2018, we moved on to our current architecture. So before we get to that, let's look a little bit at Nemo. So Nemo stands for Neat Modular. And without getting into a lot of detail, we start off with an ID, and we inject that into something called a controller. And this controller is something that controls like a view controller or a cell controller, what have you. And this controller is essentially a black box. It would then go and create something called a data source, which then creates a model. And then this model is used to bind one-on-one with the view. So the controller would give the ID to the data source, and the data source would do the fetching. It would do all sorts of fetching there, and then actually create the model itself. And then the controller would go, hey, view, prepare your view with data source.model and properties. So obviously, now there are a lot more layers here in a vertical slice. So there were some advantages to it, like introducing a pattern to follow, because we really, at the time, needed some kind of pattern and stick to it, because there was just a lot of ambiguity around how to just write good code. And then we obviously distributing code into different sort of modular, neat modules, made it a little bit better, a little bit more testable, but there were quite a few problems as well. And these problems came up more and more as we started to get more developers in and extend our feature set, basically. So I looked back, and I decided to categorize all the pain points into something like this, a table of solid principles. Who here knows solid? Anyone? Who here practices solid? Okay. Solid principles are just a really good way of ensuring that your app ticks all the boxes in terms of scaling, maintainability, just good coding practices in general. And I won't get into the detail of it, but let's just look at the pain points here. So single responsibility principle. An object shouldn't change for more than one reason. And an object should do something, one thing and one thing well. So most objects in Nemo were small, but our data source objects tend to know too much. They knew about fetching, how to fetch things from the API, model creation. It even created the model itself. And then some UI code actually leaked into there. So there was UI kit knowledge inside that data source for some reason. So that just violates single responsibility straight up. Open-close principle. An object is open for extension, but closed for modification. So what that means here is models were coupled to the UI. Like you would go label.attributed text equals model.label attributed text or something like that. So it was a direct one-to-one with, with the views. So you wouldn't really be able to extend anything from this model. You would just end up creating a new one. And same with Liskov substitution principle. This is just inheritance, kind of substituting an object. So let's try it, right? So this is off the top of my head. I'm actually just recalling this from memory. So you have an object, and this object depends on another object that has a subclass. So you can just substitute that subclass in, and that object should compile and just use that subclass just exactly how it thinks it is for the original one. So if that makes sense. So again, in Nemo, all our stuff in that vertical slice were highly specific. So you would really never subclass anything. You would just, let's just make a new Nemo stack, and so on and so forth. And interface segregation principle states that, so what would that state? So it's basically, you would objects should depend on things that they use, and you shouldn't depend on things they don't need, putting it the other way around. So there were no interfaces within that vertical. Controllers had to actually access the model to prepare the view via the data source, which just reached into the guts of all the implementation. And you would never be able to cleanly make a cut and replace things without changing a ton of implementation. So it was just totally violating this principle. And then the last one, dependency inversion. Objects should depend on abstractions and not concretions. So the controllers and data sources create the things that they depend on. What that means is you wouldn't be able to, you basically, each object just knew too much about some kind of detail. So only the model could truly be isolated because it got injected with an entity. Everything else was pretty much untestable, or parts of it were, and we just had to ignore the rest of it. So was Nemo solid? Probably not. It worked okay for a small team at the time. We wanted to follow some kind of pattern to be unified and working towards the same goal, but it doesn't really scale and meet our requirements. And we always think of software being modular. We want to just make it and arrange it the same way, but that generally never happens. It usually is something like this, where you have to think about how each feature or functionality would fit into your app, your application, and have to deal with all these different conflicts, right? So we need to pay a lot more attention to software design here to be able to scale up. And this is about the time when I was reading this book written by Robert Martin called Clean Architecture. And a lot of people would have seen this diagram somewhere in the web. So this diagram is a very, very old diagram on how Uncle Bob, that's what we call him, Uncle Bob decides to sort of distribute the software applications or things in different layers. So to set some context, let's just quickly go through this. So we have the entity in the middle. An entity represents objects in real life. They don't really rely on anything because it makes sense for these objects to exist. And that's how we would represent them. Use cases, which is the red layer, the red circle there, are the business logic and where the company defines value of the features. Then the controllers and presenters in that green ring over there would take these use case objects that are related to the business and then make that output to the view, however necessary. And the outermost layer is what we call the foundational layer. I think that's what I call it. And then where things are sort of more concrete and platform specific. For example, you'll have things like the web, UI kit, some kind of database implementation, or external interfaces or libraries that we need to actually present our data to the user and actually get it into their hands. So that sort of stuff is really, really concrete, right? And of course, the arrows that we see pointing from the outermost to innermost is where the dependencies lie. So entities don't really depend on anything, and the foundational layer sort of is everything. So think of it as the most concrete to the most abstract, most dependencies to least dependencies, most likely to change, least likely to change. And we should be thinking of it in that way. I'll expand on that a little bit more later. So how does clean architecture, and all this was sort of built on the web, right? So this sort of diagrams were all, I think his book is all basically in Java, most of it. And then all this was sort of web understanding. So how does that translate to us in iOS, right? So let's start off with a simple scenario. We have a view controller here, and this view controller needs to request some data, and then save it to the database, and then display it back to its view. So it knows about some kind of URL requesting, some sort of core data, which is like a database. And for comparison purposes, I've set them as blue, because blue is the foundational layer. And these objects rely on specific frameworks like UIKit, core data, could be even RealmDB, or AF networking, LMOfire, you name it. So what I would do is split any kind of business logic into something called an interactor, or we could call it a use case. Uncle Bob uses that term a lot, use case. And then that would be all this sort of business logic that doesn't really have anything to do with the view. But then there's also a lot of presentation logic, right? Because these objects in the web could be quite structured and hierarchical. So views like something more consumable and flat. So that's where we have a presenter. And the presenter would take care of any kind of business logic and transform that into something more presentable to the view. And then those two, core data and requests, we can just categorize them as fetcher, because that's just how we can name it. It's just something that understands how to fetch things or deal with the details of stuff. So if we look at the two objects in the middle, the use case deals with business rules and logic, and you should want to test that a lot. The presenter has obviously presentation logic, a lot of transformation logic to the view, and we should also be able to test that. And let's talk about how things communicate, like how each object communicates to one another. So We start off with the entity, so we call, obviously, using the same colors. The entity is the sort of domain objects that don't have dependencies, right? So the fetcher and interactor mainly deal with those. So the interactor would then pass that to the presenter, or depending on the case, it may create something called a data model. And then this data model would would basically just represent the use case for whatever it needs. And the presenter would take that and transform it into something called a view model. And that's how we're sort of currently looking at these different transformations. So someone that does Viper might say that this looks pretty much exactly like Viper. And also note my talk covers Viper things, but minus the router, because this 30 minutes is just not enough to talk about clean architecture and routing. So yeah, we're just gonna cover the clean architecture part. So what we do at Puntus is we really love Swift. So we take a very, very Swifty mindset and then apply that to a clean architecture principle like Viper, implementation like Viper. And then we also have RX. So we combine that, and what we get is ViperX. So let's look at a common scenario of Viper. So let's look at this scenario where we just want to fetch and display something from an entity. So we get an entity and we just want to output that directly to the view. Very, very simple. It's just a read-only screen. So what we do for Viper, if we're going to implement Viper, would be we have a presenter input protocol or interface, whichever you like to call that. And the presenter would implement it or conform to it. The view controller would then use that, hang a dependency on that to ask it to load or ask it to do stuff. And then the presenter would then use an output protocol that's implemented by the view controller to send it the view models or the data that's necessary. Make sense? So same with the fetcher. The fetcher has an input protocol that it conforms to. The presenter uses that to ask it to fetch stuff. And the presenter conforms to an output, a fetcher output, that the fetcher uses to send the data back. And this is a traditional delegation pattern where there are no bindings, there's just basically function calls. And we usually have this kind of one-way, single-directional data flow because the calls are asynchronous, most likely, and we want to split the inputs from the outputs. So how would we improve this in using a bit more reactive way? So what we do is we combine the input and output protocols into something called presenting. And we also do the same with fetching. So there's an input and an output, but now they're the same thing. But we still want it to be a single directional data flow. So how do we really do that? Which brings me to a little bit of code here. So let's dive into it. So on the top, we have a race event, a basic race. So thinking about horse racing here. So it's a race that happens, and we want to display the horses that run in a screen. So down there, you have runners. And the runner has some details and stats about it, like name, jockey, trainer, and the number of it. So that's just the entity. As you can see, it basically just imports foundation. There is no fancy things here. They're all just humble objects that are as primitive as possible. And obviously, we use decodable because that's just simple to do. Moving on to the view model, which gets more interesting. So we're talking about the data here, right? Just data are humble objects that gets passed along. So view models are a bit more flat, like this. So you have race event view model, which is the top one. Then that has a title and it houses the runner view model. So runner view model is at the bottom there. You'll have title, jockey, trainer, and all those are just strings and some stats. And then we have something called odds, which is an observable of type string. So odds in our context is something like prices, and prices change over time. Like odds change all the time, they fluctuate. So how do we model that in a reactive way? So that's why we have a string, which is what we want to display as an observable, and an observable is something that can send events across time, a stream of events across time. So that's exactly what it is. We also have something called select. That's interesting. Never seen that one. As a type any observer, and it is of type void. So, and any observer is an Rx object that you can push events to or trigger events, and that will send on next signals along. I'm not sure how many people are doing Rx, but they're basically just using observer patterns, observer and observable. These two are just hand in hand. So one is like read, one is write. So, and we have a dispose back there that handles, takes care of the bindings. So by declaring that this view model has a dispose bag, it means that this view model is responsible for the lifetime of the Rx event streams. So that means when the view model is destroyed, all these bindings would disappear as well and get cleaned up. So let's dive into the presenter here and look at the protocols. So the presenting protocol is simple. It has a view model, which is an observable, and a load function, which it relies on something to tell it to load. The race event fetching, see how basically the syntax would be the feature name and then the object itself or the interface. So race event fetching would have race as a single and odds for some kind of runner ID. So you give it a runner ID, it should give you back an observable of type double, and then that would actually, you would be able to bind to that. So what the presenter is initialized with is a fetcher. So a fetcher is some object that you implement, which is when you implement the fetching protocol. So this fetching protocol, the fetching implementation could be literally anything. It could be from a database, it could be from an API. It's really up to you how you would implement that. All you have to do is make sure that you would conform to race and odds. And the presenter itself would load in this way. So it would have the load function and ask the fetcher for the race. It would then create a view model from it and then bind it to something called a sync, which is basically just some kind of state, a reactive state that we have inside the presenter. So this is literally how we would code, or a pattern that we would code inside the presenter. And then the view model is just a wrapper, so that's a computed property in Swift, and that would wrap the sync and just filter nil, because we do not want to send nil view models to anywhere else, to the view. So let's actually look at making those view models. The top one is basic. We don't want to go through that. It's just a bunch of formatting with the race. So you just take a race and you format that, and then you take those runners, and for each one you map into a runner view model. And the runner view model is where the reactive stuff comes in. So you have your select, which is a published subject in here. So a published subject can be an observer and an observable. So it can actually be both. So, and it's of type void because we don't really need a type there. We just need to know that this view model got selected. So we subscribe, we want to handle the action of this select. Maybe we want to log some data or present a new screen. So this is where we do it in the subscribe on next. And that's also a potential place for router navigation, which I will not cover because there's just no time. And we would dispose it by the dispose bag that we create within this function. So it's all scoped within this function. There is no side effects. There is no self do anything, besides maybe potentially some sort of delegate call for routers. And then looking at odds, odds would just call the fetchers observable. So fetcher being the protocol, it doesn't actually know what object it is. It just asks for odds for this particular runner ID, and it will map it to a format, like a price format, a dollar format. And then this return would actually be the initialization where we do a bunch of formatting, and we pass the odds in as an observer. So it's actually an observer, and select is an odds is an observable, and select would be as an observer. And then we also pass the dispose back in because we want to make sure that we clean up after ourselves. So how do we use all of that? We just have a view controller that is injected with a presenter of some interface which is presenting. And we have your view model, we have a table, and then we call presenter.viewModel, get the runners from it in the subscribe block, and then we call reload data, tableview.reload data. And what the data source actually is basically just getting a cell, preparing it with the view model that it has. So this is super basic table view code that everyone has written something like this at some point. And the interesting thing is the runner's odds will be bound to the cells button, dot title, and then disposed by the cells, disposed back for reuse. And then when you want to actually tap on that cell, you have a basic did select row at index path, and then you would just get that runner view model, add that index path, and then just say select. So basically, that's all you need to create a full flow from the entity to the view and back into a new screen. So to wrap up, the more dependencies an object has, the more likely it is to change. So we should think about coding in a way that reflects what is most important to our business. And how we do that is to use interfaces and protocols to guard and protect against any kind of change. So there is no one-size-fits-all. The earlier example I showed is the interactor being unnecessary because there's no business logic and it was only required to have presentation logic. So hence a more simplified version of the clean architecture. Conversely, I think we shouldn't limit ourselves to only those components. Feel free to have as many layers as necessary or as little as necessary that fits your needs, right? And of course, using reactive frameworks like I did in that example was really awesome and it allowed us to eliminate a lot of boilerplate code that people would shy away from when implementing Viper. And yeah, just use it to supercharge all the interactions and have a unidirectional data flow. And again, clean architecture is not, any implementation of clean architecture is not really a silver bullet at all. But with these concepts, you would be able to go far and you can craft your own silver bullet. And that's really all I have. Since we're not having any questions, thank you all.